This presentation reviews the drawing process for characterized resources. The figure shows a combi load truck preceded by a queue called a truck's weight, which are linked by the link TR1. The definition of the link is through the link statement that takes as an argument the name of the link, TR1, followed by the name of the predecessor, truck's weight, and the successor, load truck. In order for combi activity load truck to be able to create an instance, the enough attribute for link TR1 must have the logical value true. The logical value of the enough attribute is determined by logical expression. The default logical expression compares the current count in truck's weight to the value 0. This logical expression is true if there are any resources in queue truck's weight. The remaining 4 statements apply after the combi has created an instance. The first of these statements, draw order, is not used very often. The purpose of statement draw order is to resort the resources in queue truck's weight in a different order. This is very similar to the discipline statement that also takes a cursor expression and rearranges all the resources in a queue according to that cursor expression. In essence, the statement draw order sorts the resources in queue truck's weight using cursor expression as the sort key. Similar to discipline, resources for which the cursor expression is smaller go to the front of the queue, and resources for which the cursor expression is large go to the back of the queue. This resorting of the resources in queue is not permanent. It is only in effect while a link TR1 draws resources. After the drawing process is completed, the resources go back to their original order. The default cursor expression is null. In other words, the resources are not resorted. They remain in their original order. The next 3 statements perform the actual drawing process. The first statement, draw until, controls the number of times that link TR1 will draw resources from truck's weight. These resources will be drawn one at a time, and the draw until regulates how many times TR1 will be able to draw from the preceding queue. Drawing continues until the logical expression of draw until becomes true. The default logical expression is that the number of draws through link TR1 is greater than or equal to 1, which means that link TR1 is allowed to draw once. The draw where statement determines which resources link TR1 is allowed to draw from the preceding queue truck's weight. Link TR1 will cursor the resources in truck's weight, starting with the resource at the front of the queue, and apply the logical filter expression with cursor variable to that resource. If the result of that expression is true, then link TR1 will draw that resource. If the result of that expression is false, then link TR1 will bypass that resource and move on to the resource behind it in the queue. The default logical expression is 1, which means that TR1 will be able to draw the resource at the front of the queue. When link TR1 draws a resource from the preceding queue, it also executes the argument of the draw duration statement. The draw duration expression provides a mechanism by which to sample expressions that can be used to determine the duration of each draw in terms of time. The default expression for the duration expression is 0. Link TR1 draws resources from the preceding queue one at a time. After a resource is drawn, the process continues by re-evaluating the logical expression for draw until. Drawing will continue as long as the condition for draw until is false. Once that condition becomes true, the drawing process ends. This is a summary of stroboscope statements related to characterized resources. At the beginning, we have the statements that define characterized resources. We have simple characterized resources as well as compound characterized resources. For simple characterized resources, we have two statements. The car type statement defines the type, and the subtype statement defines subtypes of a particular type. Compound characterized resources are simpler to define. They use the statement comtype followed by the type of the compound characterized type. In addition to the properties of characterized resources, we can also define persistent assignable properties called save props. These are defined with the save props statement followed by the name of the characterized type followed by a series of save prop properties. We can also define properties that define formulas. These are defined by the var prop statement, which takes as an argument the name of a characterized type, the name of a property, and an anonymous cursored expression. The anonymous cursored expression can reference any other property of that particular type. This includes the properties defined by car type as well as the save props defined for that characterized type. It also includes any other var props defined for that characterized type. Characterized queues are initialized with the init statement. There are two types. For simple characterized queues, the init statement takes the name of the queue, a positive integer expression, and the name of a subtype. When this statement is executed, Stroboscope creates as many objects of that particular subtype as specified by the positive integer expression, and then each one of those objects created enters the queue simple characterized queue one at a time. The init statement for compound characterized queues takes as an argument the name of the queue followed by a positive integer expression. There is no need to specify the subtype after that because compound characterized resources do not have subtypes. The order by which resources are stored in a queue is defined by the discipline statement, which takes the name of the queue and a cursored expression. The cursored expression is essentially a key by which the resources are sorted inside the queue. Resources whose value of cursored expression is smaller go towards the front of the queue, whereas resources whose cursored expression is larger go towards the back of the queue. The enough attribute of a link controls whether the queue contents preceding the link can support the start of a combi. The enough attribute takes the name of a characterized link out of a queue and is followed by a logical expression. If that logical expression is true, then the enough attribute is true. The next three statements control the drawing process from a queue. They are draw order, draw until, and draw where. All three of them apply to a link out of a queue that goes into a combi. In addition, the draw duration statement allows the collection of statistics about the duration of each draw. Finally, the last three statements control the releasing of resources from terminating activity instances. Release until, release order, and release where are very similar to draw order, draw until, and draw where. These statements are defined in more detail in the Stroboscope dissertation.